This is how-to videos, force example 1B, some more F equals ma. It kind of goes along with the previous setup of pushing a book. Very exciting. We draw out the diagram. We have gravitational force, or we can also indicate that as weight. There's a normal force and force of friction. It's already in motion, so we would not be including the applied force from Ethan. Okay, let's see, we can also include the okay, so we draw in this is where the initial velocity is. Here's the final velocity. It's accelerating to the left, so even though it is moving along this way to the right, it is in fact accelerating to the right. And we have a displacement here, displacement. Then we can list out the information. Okay, initial velocity, final velocity, acceleration, displacement, time. And we might as well also list out gravitational force or weight. So the initial velocity we're not given, but we probably don't care about it. Final velocity, it comes to a stop. Acceleration, once again, we're going to be looking for this because we're going to have to use F equals ma in order to figure out the friction. Displacement is going to be 0.8 meters. The time, 1.2 seconds. The gravitational force or weight is given to us as 11 newtons. The first thing we're going to be doing in order to solve for the acceleration is right here. We're going to be using one of the big five equations, the one without initial velocity in it, which is d equals vf t minus 1/2 a t squared. Final velocity is 0, so that whole thing goes away. So we're solving d equals negative 1/2 a t squared. That was a t. Okay, rearranging for a, we got a is negative 2d over t squared. We plug in, we have negative 2 parenthesis 0.8 meters close parenthesis divided by 1.2 seconds parenthesis squared. Tap that into our calculator, we get negative 1.11 meters per second squared. Okay, that is our acceleration. Let me change to a different color here, talk about what we're going to do with the weight in order to turn it into mass. Weight, or gravitational force, is equal to mg. The F equals ma uses mass and not weight, so we'll need to convert this. Mass is equal to W divided by G. So let's go ahead and plug in. We have 11 newtons divided by 9.8 meters per second squared. You say, oh, what about the negative sign? We can just kind of ignore that because, remember, technically weight is a downward force, so that should have had a negative sign here, and that means that's going to cancel out that negative sign. Anyhow, we just end up with a positive value for mass, of course. That would be 1.12 kilograms. And then finally, now we can figure out what the force of friction is. Force equals mass times acceleration. The only force on the x-axis is going to be the frictional force. So equals mass times acceleration, which equals 1.12 kilograms, parenthesis, negative 1.11 meters per second squared, parenthesis, and force of friction, tapping into our calculator, negative 1.2 newtons. So in this one, the difference was we were given the weight instead of the mass of the textbook, and we just had to convert it. But that was easy enough.